Hey guys, today we're going to do section 1.4, measuring and classifying angles. Make sure you have your notes and a pencil ready. Take a few minutes and solve this warm-up here, solving for each of these equations for x. Okay, in case you need a refresher, number one, I solved this one for us. On the left-hand side, you combine like terms. 5x plus 2x is 7x, and then a positive 6 minus 14 is negative 8. Move the 8 over by adding 8 on both sides, and then divide both sides by 7. 7 goes into 9 once with 2 left over, and 7 goes into 28 4 times. So for number 1, the value of x is 14. All right, number 2, go ahead and try this one. The answer to number 2, combining like terms, 4x plus, this is understood to be a 1 here, is 5x. Negative 30 plus 25 is a negative 5. Add 5 to both sides using the inverse operations. And then divide both sides by 5. 185 divided by 5. 5 goes into 18 3 times with 3 left over, so 5 goes into 35 7 times. All right, angles. Angles are created by two rays that meet at a vertex. So draw this figure. Here is our vertex. H is our vertex here. There are 3 ways to name this angle. We can say angle FHP. Notice we go and we do F to H and then H to P. That would mean that we're talking about this angle right here. Since H is a vertex of only one angle, we are allowed to call this angle H. And we can also call this angle PHF. All 3 of these mean the same thing. Notice H, the vertex has to be in the middle when you are naming your angle. All right, classifying angles by degrees. There are 4 types of angles. An acute angle measures less than 90 degrees. A right angle measures exactly 90 degrees. An obtuse angle measures between 90 degrees and 180 degrees. And a straight angle measures exactly 80 degrees. Write these 4 down. Let me change this one thing here, because in your next class, you're going to be dealing with angles that are bigger than 180. So let's just say this will be measures greater than 90 degrees. Looking here are the degrees. A straight line is 180 degrees. That's a straight angle. 90 degrees makes a right angle there. And if we look here, angle FEG is acute, and HEF makes 90 and HED makes 90. And the way you would say a straight angle, you would say angle FED is a straight angle, or angle DEF is a straight angle. All right, angle addition postulate. Follow along and write down this postulate. If P is in the interior of angle RST. So visually you should be thinking about an angle that has a vertex S and the rays SR and ST. Then the measure of angle RST is equal to the sum of the measures of RSP and angle PST. Here is a visual representation of angle RST, and P is in the interior, so between R and T. So creating this ray SP, we now have these 2 smaller angles. They do not have to be congruent. So if you notice here, these are called arcs. So RSP and PST added together gives us RST. So go ahead and write down the equation here that represents the angle addition postulate. Very similar to the line segment addition postulate that we learned in a previous section. All right, what is the measure of angle XYW? Draw this figure. XYW, I'm tracing my pen here. XYW is this angle right here. We're given that XYZ is 100 degrees, and we are allowed to assume that straight angles are how much? Look back in your notes. How much is a straight angle? If you said 180, you are correct. So angle XYW, angle XYZ equals angle, the measure of angle WYZ. This is the one we are looking for. This is 100 degrees. And WYZ, it's a straight angle. You are allowed to assume it is 180 degrees. So the measure of angle XYW, 100 on both sides. The measure of XYW is 80 degrees. And in some books you'll see a little m here which represents the measure. So the measure of angle XYW is 80 degrees. All right, going back to how we use the segment addition postulate and our idea of having variables and solving information, same thing applies here. We're going to be using the angle addition postulate, and we are given different pieces of information for each angle. So we are solving to find x from our equations here, and then the measure of angles ABD and DBC, so these individual angles here. We are given the measure of angle ABC, the big angle is 122, and we're given algebraic expressions for each of the individual angles. So using the angle addition postulate, we are going to set angle ABD plus DBC is equal to the entire thing. So 8x plus 20, that added to 22x minus that equal to 122. This looks very similar to our warm-up problem. That's why I had them there. So go ahead and solve this equation for x. If you got 3.5, you are correct. Or if you wrote that as 21 over 6, that also is okay. 3.5 is what I'm going to write here. And now we need to know the measure of the individual angles ABD, this one, and DBC. So what do we do with that 3.5 in order to find them? If you thought plugging in, that's great. So the measure of ABD, we're going to use this equation here and plugging in 3.5 for x. So 8 times 3.5 plus 20. Go ahead and simplify that out. If you got 48, you are correct there. And now let's find the measure of DBC. Oop, wrong thing here. All right, measure of DBC, that is the 22x minus 3. 22 times 3.5 minus 3. Go ahead and simplify that out to find the measure of angle DBC up here. If you said 74, you are correct. All right. Let's look at this example here. The measure of CDB, this top one here, is the expression 8y plus 8 degrees. The measure of angle BDC DA, this little guy here, is 5y minus 3, and the measure of ADC, the big I, is 70 degrees. Go ahead and follow what we did in the previous example and find the measure of CDB and the measure of angle BDA. Make sure you show all your steps in your work. All right, going through the angle addition postulate, angle CDB plus angle BDA equals angle ADC. I replaced each of these three with what each of those angles represent in the problem. I put parentheses around them because the parentheses were given there, and I just rewrote them since addition. We're not distributing anything. We are allowed to take the parentheses away because 8y and 8 are unlike terms, and same thing with 5y and negative 3. Combining like terms, 13y, 8 minus 3 is 5, move 5 over. 65 divided by 13 is 5. Y equals 5. Do not stop there. Look back at the question. It says find the measure of angle CDB and the measure of angle BDA. Plugging the 5 in for y, you get 40 plus 8, so 48, and then 25 minus 3, so 22 as those two answers there. Go ahead and check your work. If you made a mistake, check to see where it is. Star in your notes if you have questions with this one, and you can ask it next class or send me a Schoology message. Congruent angles. Congruent means the same measures that have the same measure. The way that you denote congruent angles here, if these are congruent, you would draw one arc for each one. That would mean that those two angles are congruent. Another way, if you have another piece, you can use two arcs that could represent that each of these two are congruent. So these two on the right here are congruent to each other. These two on the left here are congruent to each other. Angle bisector. Think back to what a segment bisector is. What is a segment bisector? A segment bisector is a point, ray, or line segment that intersects a line segment at the midpoint. So it divides it into two congruent line segments. Here, an angle bisector divides an angle into two congruent angles. So here, the teal color blue is the angle bisector of this big one and would result in two congruent angles. So both of these in blue are angle bisectors. Take a few minutes and draw these two. All right, trying this one here. XB is the angle bisector of angle AXC. Once they draw in your arc to show that they are equal, you are given a measure of AXB is 23. So to find the measure of each of them, because they're equal, so x plus x equals 23, 2, 3, so x equals 23 divided by 2, which is 11.5. They are congruent to each other, so both BXC and angle AXC are both 11.5. Whoop. I did not do that right, did I? AXB is 23, so I wrote these all wrong. My bad. Scratched all of that. Whoop. All right. XB is the angle bisector of AXC, so that means that these two angles are congruent. Draw in your arcs here. AXB is right here, 23. Angle bisector tells us that AXB is congruent to angle BXC. So that would be this one, 23. Adding those together, plus 23 would give us 46 for our angle here. Let me know if you guys have any questions. Thanks, guys.